If it needs, it'll retrieve information, augments its understanding, and generate answer for us. Rather than retrieving data, it now generates answers. Fundamentally changed how computing is done. Every single layer of computing has been transformed. The last several years, the last couple, 2-3 years, major breakthrough happened. Fundamental advance in artificial intelligence. We call it Agentic AI. Agentic AI basically means that you have an AI that has agency. It can perceive and understand the context of the circumstance. It can reason, very importantly, it can reason about how to answer or how to solve a problem. And it can plan in action. It can plan and take action. It can use tools because it now understands multimodality information. It can go to a website and look at the format of the website, words and videos, maybe even play a video. Learns from what it learns from that website, understands it, and come back and use that information, use that newfound knowledge to do its job. Agentic AI. At the foundation of agentic AI, of course, something that's very new, reasoning. And then, of course, the next wave is already happening. We're going to talk a lot about that today. Robotics, which has been enabled by physical AI. AI that understands the physical world. It understands things like friction and inertia, cause and effect, object permanence. When something goes around the corner, it doesn't mean it's disappeared from this universe. It's still there, just not seeable. And so that ability to understand the physical world, the three-dimensional world, is what's going to enable a new era of AI we call physical AI, and it's going to enable robotics. Each one of these phases, each one of these waves opens up new market opportunities for all of us. It brings more and new partners to GTC. As a result, GTC is now jam-packed. The only way to hold more people at GTC is we're going to have to grow San Jose. And we're working on it. We got a lot of land to work with. We got to grow San Jose. So that we can make GTC look. I have this, just, you know, as I'm standing here, I wish all of you could see what I see. And we're in the middle of a stadium. And last year was the first year back that we did this live. And it was like a rock concert. And it was described, GTC was described as the Woodstock of AI. And this year it's described as the Super Bowl of AI. The only difference is everybody wins at this Super Bowl. Everybody's a winner. And so every single year, more people come because AI is able to solve more interesting problems for more industries and more companies. And this year, we're going to talk a lot about agentic AI and physical AI. At its core, what enables each wave and each phase of AI, three fundamental matters are involved. The first is how do you solve the data problem? And the reason why that's important is because AI is a data-driven computer science approach. It needs data to learn from. It needs digital experience to learn from, to learn knowledge and to gain digital experience. How do you solve the data problem? The second is how do you solve the training problem without human in the loop? The reason why human in the loop is fundamentally challenging is because we only have so much time, and we would like an AI to be able to learn at superhuman rates, at super real-time rates, and to be able to learn at a scale that no humans can keep up with. And so the second question is, how do you train the model? And the third is, how do you scale? How do you find an algorithm whereby the more resource you provide, whatever the resource is, the smarter the AI becomes? The scaling law. Well, this last year, this is where almost the entire world got it wrong. The computation requirement, the scaling law of AI is more resilient and, in fact, hyper-accelerated. The amount of computation we need at this point as a result of agentic AI, as a result of reasoning, is easily 100 times more than we thought we needed this time last year. And let's reason about why that's true. The first part is let's just go from what the AI can do. Let me work backwards. Agentic AI, as I mentioned, at this foundation is reasoning. We now have AIs that can reason, which is fundamentally about breaking a problem down step by step. Maybe it approaches a problem in a few different ways and selects the best answer. Maybe it solves the same problem in a variety of ways and ensure it has the same answer, consistency checking. Or maybe after it's done deriving the answer, it plugs it back into the equation, maybe a quadratic equation, to confirm that, in fact, that's the right answer, instead of just one shot blurbing it out. Remember, 2 years ago, when we started working with ChatGPT, a miracle as it was, many complicated questions and many simple questions, it simply can't get right, and it's understandably so. It took a one-shot, whatever it learned by studying pre-trained data, whatever it saw from other experiences, pre-trained data, it does a one-shot, blurps it out, like a savant. Now, we have AIs that can reason step by step by step, using a technology called chain of thought, best of N, consistency checking, a variety of different path planning, a variety of different techniques. We now have AIs that can reason, break a problem down, reason, step by step by step. Well, you could imagine, as a result, the number of tokens we generate, and the fundamental technology of AI is still the same. Generate the next token, predict the next token. It's just that the next token now makes up step one. Then the next token after that, after it generates step one, that step one has gone into the input of the AI again as it generates step two, and step three, and step four. So instead of just generating one token or one word after next, it generates a sequence of words that represents a step of reasoning. The amount of tokens that's generated as a result is substantially higher, and I'll show you in a second. Easily 100 times more. Now, 100 times more, what does that mean? Well, it could generate 100 times more tokens, and you can see that happening, as I explained previously. Or, the model is more complex. It generates 10 times more tokens, and in order for us to keep the model responsive, interactive, so that we don't lose our patience waiting for it to think, we now have to compute 10 times faster. And so 10 times tokens, 10 times faster, the amount of computation we have to do is 100 times more easily. And so you're going to see this in the rest of the presentation. The amount of computation we have to do for inference is dramatically higher than it used to be. Well, the question then becomes, how do we teach an AI how to do what I just described? How to execute this chain of thought? Well, one method is you have to teach the AI how to reason. And as I mentioned earlier, in training, there are two fundamental problems we have to solve. Where does the data come from? Where does the data come from? And how do we not have it be limited by human in the loop? There's only so much data and so much human demonstration we can perform. And so this is the big breakthrough in the last couple of years.